Good morning. Today, let us begin a new chapter on hardware and software overview. In hardware and software overview, we shall basically cover three broad topics. First of all, the hardware concepts, then the software concepts, and finally, the networking concepts, and spanning two lectures. First, let us see the hardware concepts. Uh, Computer hardware, as we all know, essentially has the following components. There is a central processing unit co consisting of an arithmetic logic unit and a control unit. Then we have the input devices such as keyboard, computer mouse, touch screen, source data automation, etc. Output devices like printers, plotters, etc. Secondary storage, magnetic disk, optical disk, magnetic tape, etc. Communication devices, and a primary storage, basically the random access memory, and the connection with the central processing unit to all these different devices are done through the different buses. So, as you can see here, then important terminologies that are important in this context are the first of all, bits and bytes, ASCII, American Standard Code for Information Interchange, EBCDIC, Extended Binary Coded Decimal Interchange Code, the different kinds of parity bits, then pixel 1024 into 768, just for example, VGA standard grid, then CPU and primary storage, machine cycle, processing speed, the millisecond, microsecond, nanosecond, picosecond, etc. Storage or memory size, random access memory, read-only memory, programmable read-only memory, and finally erasable programmable read-only memory. So, let us just quickly try to understand the concepts. Basically, everything about computer are consisting of zeros and ones, so they can be called as bits. Now, essentially when 8 bits combine together, you can call it a byte, and one byte is usually used to code one alphabet or one letter. So, the various systems are there, like the famous ASCII code, the American Standard Code for Information Interchange, or the EBCD code, Extended Binary Coded Decimal Interchange code. They are basically codes how to write alphabets and letters, and also numbers, special symbols, etc. Using a byte of information. Now, sometimes what happens, usually a parity bit is also added. The parity bit, as you have seen, is like a redundancy. So, if there is an error in transmission, this transmission error can be taken care of with the help of the parity bit. The pixel on the other side is a point on the terminal. So, basically the VGA standard grid has 1024 into 768 so many points or pixels by which we have the particular terminal screen. Then a CPU and the primary storage, these are very important. The main computer processing takes place with the help of the primary storage and the central processing unit, and we know that while these calculations go on, the time taken is absolutely fixed. There cannot be any variation. Every addition process will take the same amount of time, and it depends on the machine cycle, right. So, this machine cycle is basically related to the processing speed. So, suppose we have something like 266 megahertz, which in today's standard is quite low, is equivalent to 3.76 nanoseconds processing speed. So, the processing speed in milliseconds, microseconds, nanoseconds or picoseconds is equivalent to the clock, right. So, we know that every system has a clock with a given clock speed, and this particular clock speed is related to the processing speed as well. Then the storage or the memory size such as the kilobyte, megabyte, gigabyte, for example a 30 GB hard disk. Then we have different types of memory such as the random access memory, the volatile memory which does not exist once the power goes off, read only memory or ROM. The ROM is something which you can just write once and then you cannot use it, you cannot write anything anymore. So, essentially the basic idea of a ROM is keeping some system specific instructions which along with the hardware constitute the basic operating system. Then a PROM, from programmable read only memory, that part of the read only memory which you can program, erasable programmable read only memory or EPROM. Then once we see all these important terminologies, then let us see the various generations of computer hardware. So, let us talk about 4 generations of computer hardware. In the very first generation, we had the vacuum tube technology, is a very old 1946 to 1956, and at that time the entire computer used to cover an entire room altogether. It is a very large room covering only one computer. Then we have the transistors, the second generation computers 57 to 63, third generation using integrated circuits 64 to 79. Then from 80 onwards we have the fourth generation computers, they are very large scale integrated circuits. So, these are the various generations of computer. Evolution has taken place in a tremendous manner. At one point of time when the DOS, the so called disk operating system, was first begun, 640 KB was thought to be a good enough memory area for random access. Today even 640 MB is found to be less, right. So, you see a jump from 640 kilobyte to 640 megabyte has just happened in last 20 years or so. So, you can see how the entire computer hardware changes are taking place in an exponential manner. Then microprocessor. The basic idea of microprocessor is, in a very simply you can define the computer on a chip. VLSI technology integrates the computer's memory, logic and control on a single chip. So, there are various microprocessor chips, the 8286, 386, 486, then we have Pentium 1, 2, 3, 4, etc. Similarly, some numbers from Motorola. So, these are basically can be called as microprocessor. Then the microprocessor performance, some important terms here, megahertz, word length, data bus width. The first of all, the megahertz is a measure of cycle speed or the pacing of events on a computer. So, basically whenever the system clock is there and every time you are processing something, let us say adding 2 numbers, it has to go through some very well specified steps, and these well specified steps are the time taken therefore will be defined by the whatever is the system clock, and this system clock or the cycle speed will depend how much time it will take on the megahertz. Then word length, number of bits that can be processed at one time by the machine. So, you can have 8 bit, 16 bit or even 32 bit word lengths, right. Data bus width, the data bus acts as a highway between the CPU, primary storage and other devices. Determining how much data can be moved at one time, 16 bit 32 bit, 64 bit, etc. Alright. So, more you have the data bus width, more information can flow. So, essentially we have basically two important things. One is the processing speed and the IO speed. You see, the processing speed depends on the word length, on the megahertz, the frequency. Now, you see that if the word length is more, if the megahertz clock speed is more, then what will happen? You can process your system faster, right? The system is faster as far as processing is concerned. But again, every processing, so if you see that original diagram, maybe it will help us little bit. You see, if the processing actually goes on in the central processing unit itself, right, then things are pretty fast because processing speeds are very fast. Whereas if you have to keep on getting data from the primary storage, it will be slightly slower, but even then nothing much, because after all this is in the main bus, and the speed is very high. But every time you have to bring some data from input device or put it to the output device or bring it from communication device or secondary storage, then the speed drops drastically. So, essentially if you want the computer processing time, so the differences could be almost 1:1000. That means if some processing goes on directly in the central processing unit along with the primary storage, the time taken is 1. The any processing that has to take place along with the input device, output device or secondary storage or communication device can be order of 100 to 1000. So, you can see that to that extent the speed varies, and therefore, even if there are 2 IO operations and 100 what you call processing operations, the speed is guided by the IO operation because it is 100 to 1000 times slower, right. So, that is why the computer speed, irrespective of very good clock speed and very good everything from the processor point of view, the parallel processor and so on, if the IO speed is not good, the computer performance will not appear very drastically different, because end of the day that will guide the ultimate time taken by the computer for certain operations. So, therefore, the data bus width is very important as far as IO speed is concerned. Then we have sometimes we have the RISC computers, the reduced instruction set computing technology used to enhance the speed of the microprocessor by embedding only the most frequently used instructions on a chip, right. So, instead of the crowding the chip with too many instructions, you have only reduced instruction set. Because you have the reduced instruction set and rest of it through computation, then the machine can become actually faster. So, this is a special type of instruction set. Then in the earlier days, it is for historical reason we should know that we used to differentiate between mainframe computers, the mini computers and the microcomputers. Alright. So, mainframe, mini and micro. But today these differences has actually vanished, because whatever was thought to be the mainframe computing power, the mainframe computing power is now available even in the microcomputer, in the personal computers. All right. So, these differences has really vanished. The computers now, earlier the mainframe or mini computers used to have specialized operating systems such as Unix, Solaris and so on. Today we can have Linux in microcomputers or even personal computers configuration, that is Intel based configuration, where you can almost get the same facility. So, basically I would say that today if you do computer classifications, we should differentiate not by main, mini or micro, but by low end and high end, right. You can in the low end you may not bother about parallel processing, you may not bother about large data storage, you may not bother about uh, very good data bus width and so on, and therefore the loading Linux able to support multiple terminals. So those are the basic criteria, and the price differential can also be pretty high. It can be as high as 10 to 20 times then a low end computer, personal computer, which one would like to use for personal purpose. Then some of the important thing, the like workstation. Workstations are desktop machines with powerful graphic and mathematical capability and the ability to perform several tasks at once. So that is the concept of workstation. Today, even the ability to perform several tasks at once is also available in the latest Windows systems. That means the multitasking capability. The supercomputers are highly sophisticated and powerful computers that can perform very complex computations extremely rapidly, because supercomputers are used in specific applications of, let us say, astronomical calculations, then finite element analysis, the kind of problems where you have a very large amount of calculations to be done. Sometimes if you really calculate the time requirement, sometimes you may find the time requirement could be in years together, right. If you use an ordinary computer and to solve the problem, it might require somewhere around 5 years. So you cannot really wait years together. So you have to find ways and means by which you can solve the problem in reasonably short time, maybe few days. So you basically require supercomputers for those kind of problems. Regular day-to-day problems, I don't think supercomputers are really necessary. The basic idea of supercomputers, basically, one very important thing is parallel computation, right? Distributed computation. So it brings us there. Distributed processing, distribution of computer processing work among multiple computers linked by a communication network. So distributed processing is only possible only when you can break down the problem into small modular sizes. So you have say, for example, if it is a matrix computation, we know that most of the matrix computation requires similar operations. Alright. So if you do matrix multiplication, let us say a very large matrix multiplication, it is basically multiply element to the corresponding element and finally summing them up, all these multiplications. So if we distribute the job of multiplying each computation to each processor, then every processor will compute and everything will be fetched and summed in another processor. So it can save time, right. So instead of one particular processor doing the whole thing in a serial manner. Then we have the centralized processing. The processing that can be accomplished by one large central computer is not the proper idea today. Downsizing, the process of transferring applications from large computers to smaller ones. Then parallel processing, the type of processing in which more than one instruction can be processed at a time by breaking down a problem into smaller parts and processing them simultaneously with multiple processors. Let me repeat once again. Parallel processing is a type of processing in which more than one instruction can be processed at a time by breaking down a problem into smaller parts and processing them simultaneously with multiple processors. So here is an example of the parallel processing. In the sequential processing, we have the program to CPU, to program to CPU to result, right. So program to CPU, if you have to fetch parameters and things like that, that is happening in the same computer and it is called sequential processing. In case of parallel processing, the program breaks the problem into different parts and individual CPU parallelly processes the various tasks and the result is combined out of the results of 4 CPU, and that is fed back to the program. So that will definitely save time. That is the basic idea. Then various kinds of data storage. Now again we have to differentiate between primary storage and secondary storage. First let us see the primary storage. The primary storage are basically three types: the register, cache and the RAM. Register, temporary storage of locations in the ALU, arithmetic logic unit, or the control unit, where small amount of data and instructions reside for thousandths of a second just before use. So essentially, suppose you bring some data elements on instruction into the computer CPU, you have to hold them somewhere, and this holding is done in the various registers, right. So that is actually registers. The registers are totally volatile. That means that is used only for the thousandths of a second just before use. So it is like fetch and calculate. It is used in the next cycle step. So those are usually called registers. So if you really look at the registers contents of a computer, you will see it is changing all the time, right. It is not at all static, not at all. Cache on the other side, the high speed storage of frequently used instructions and data. So it is really not permanent, but it is also you can call it temporarily permanent, something like that. That is something, you can, even if you analyze the register contents, you will find that some register contents are such which are more or less you are bringing the same thing over and over again. So the question is, why bring the same thing, same instruction and data over and over again? Store it somewhere in the CPU and make use of them. All right. So probably it will reduce time. So some calculations has been done, and it has been found out that if we define some cache area where you store these kind of frequently used instructions and data, then probably you can actually speed up the whole thing. Please remember, everything is happening in the primary storage. We are not talking about hard disk or input output devices or communication devices, because they are all low speed. They are highly low speed, and because of their low speed, every time you fetch from low speed device like a hard disk, your the computation time will go up tremendously, to the tune of 100 to 1000 times. Those they are slow to that extent. So that is where the cache comes in, right, that you have registers, and registers are overcrowded, so make use of cache. RAM is the high speed storage of large amount of data. Everything happens inside the RAM. That is RAM, and then we have the secondary storage. The secondary storage is relatively long term non-volatile storage of data outside CPU and the primary storage, such as hard disk, floppy diskettes, optical disks, etc. The secondary storage is really necessary because you cannot carry all your information, and CPU is volatile, it will go away moment power is switched off. So you have to store your results, you have to store your programs, you have to store your databases somewhere. That is your secondary storage. So little bit values, some simple values may not be up to date, but at least it will give some indication. So some primary and secondary storage values. So register storage capacity say 1 KB and access time 0.01, cache 1 KB 0.1 microsecond, RAM 16 MB 0.5 microsecond. So you can see that register's access time is very low, whereas look at the access times for hard disk and diskettes, optical disk, magnetic tape, etc. They are in milliseconds. So and even seconds for magnetic tape. So you can understand, well understand, if you have to fetch data from hard disk and then calculate, then the maximum time will go here. If you have to read and write, that will go 30 milliseconds, and even if there are thousands of operations, altogether there may be 1 or 2 milliseconds. So total processing time is 32 milliseconds, where 30 milliseconds is IO time. So IO time is the major time in computation, and any program that misutilizes the IO time will be highly inefficient. Then the various kinds of optical disks like CD-ROM, compact disk, read-only memory, CD read-write, then WOM, write once, read many, rewritable magneto-optical disks. So now I think the future is here, that more and more of different kinds of optical disks should come in, and a day will come when we may not even like to use hard disks. We should have our removable high capacity optical disk with us, and moment we put it in the standard computer, then we get the environment we desire. See, ultimately, even today you go to a particular computer and you have to work in as per the hard disk of that computer, which you cannot touch. But if you carry your own hard disk, all you do, you insert your own hard disk, and immediately that computer becomes exactly the way you want it to be. All right. So that is how the future is. Then there are various kinds of input devices like the keyboard, the computer mouse, various kinds of touch screens, source data automation, some way, for example, the electric meter, you can probably take it from pump top, and if you enter it in your pump top, or even today in your mobile phone again in itself maybe, and there is some way by which you connect your mobile phone to the computer, then the source data is taken in an automatic manner. Then MICR, magnetic ink character recorder, OCR, optical character recorder, the digital scanners, voice input devices, various kinds of sensors and transducers which are used in scientific experiments, all right, to read temperature, pressure, and similar type of data. Then we have a little bit explanation. Source data automation, capture data at the time and place when it is created, like the, as I said, the mobile phone or the pump tops. Magnetic ink character recognition, read the bank checking account and the check number in banking application. Optical character recognition, barcodes, pen based inputs, collect data directly from the environment. Then output devices, very simple output devices, the video display terminal or the cathode ray tube. We have used what is known as the bit mapping technology to address and manipulate each pixel on the computer screen, and we may even go up to very high resolution computer terminals. Then we have the printers like line printers, you can have page printers, you can have dot matrix printer, which are no more in not so much popular anymore. The letter quality printers, the laser printers of various types, the jet printers, various kinds of plotters, the voice output devices, and so on. Now let us come to an important discussion, that is on the processing. Here, whenever we think of computer processing, essentially we should differentiate between what is known as the batch processing versus online processing. The idea of a batch processing is that batch processing is a method of collecting and processing data in which transactions are accumulated and stored until a convenient time to process in a group. Online, whereas, is a method of collecting and processing data by directly entering transactions into the computer for immediate processing. So basic difference between the two is that suppose in a banking application, what is happening, you have your bank account and you have your various withdrawal and deposit that is taking place all the time. your salary is being deposited, you are withdrawing some money. Now, at any point of time, usually what is happening in the bank, it is processed online. Moment you deposited some money, immediately it is updated into the database, your balance is calculated, and you know your updated balance at a given point of time. Suppose the same thing would have been done in the batch mode, what would have happened? You wouldn't be able to know your balance at a given point of time. All your deposits and all your withdrawals will be stored as transactions, and your opening balance of the month will be also available, like we do in accounting. And at the end of the month, we calculate what is the total withdrawal, we also calculate what is the total receipt, and then we can calculate the closing balance. So, this is one simple way it can be done. So, this is usually called batch processing. Now, you can see the batch processing is useful in some situations, specifically in month end applications like accounting, financial accounting, which you may not be interested in intermediate figures, but every now and then you may also use it for payroll purposes. Salaries usually is a month end activity. Whenever you do what you call so called batch processing, we have the transaction file, we have the master file. The transaction file is a file where transactions are accumulated for batch processing, right. The master file is a file that contains all permanent information and is updated during processing by transaction data, right. So, that is the basic idea, the master file and the transaction file. Master file is that file which is like your payroll master or your account master or your bank balance, customer details. So, basically what happens, all your balance information which you are updating, which you want to know at an instant of time, they are like a master information, whereas all those withdrawals, all those deposits which are like transactions, they will be accumulated in the transaction file. We use the transaction file to update the master file. Here is an example of batch processing. Batch processing, what happens, all the transactions, they are accumulated, and these accumulated transactions are sorted, and after sorted we have the sorted transactions, and on the other side we have the master, right. So, we have the sorted transaction, we have the master, and we process. When we process, we get the new master, we get a report, and we also get an error report. So, this is a very conventional batch processing diagram. Probably it is age old, right, it is age old, but even today it has some use, because obviously the old master new master concepts has been abolished. We use a database today, so we have a database and we have the process, and it is an update. Basically, you see why old master and new master was used. The basic idea was, the old master, if you keep, you can have what is known as a historical image. Now, due to whatever reason, suppose your these particular process goes wrong, like power goes off or something happens, and you are somewhere in the middle, then naturally you cannot neither your old master is, if you are updating in the same file or in the same database, suppose power goes in between, then you can you get back the master before the transaction was taking place. If this is not possible, then you are in a situation where you do not know how far of the transaction has been actually updated. Now, it is very easy to say, why not run the whole transaction again, but the point is, once some money has been deposited to your account, by depositing those amounts again will not get the correct figure, your account figures will vary. So, running same transaction twice is not the answer. Answer is, there should be a facility to rolling back the file or the database to a condition where it was before the transactions were actually being done. So, that is why in the old days using sequential file, they used to keep the old master and new master separate, and most of the COBOL applications of old days are written in this manner, right. In today's context, most of the modern databases, they have what is called a rollback facility. Again, the rollback facility is done with the help of transaction images. So, whenever you have transactions, you have the transaction images already kept, you have the checkpoints, you have the sync points. So, all these are used to basically roll back the database as if the transaction has not taken place. In other words, from an intermediate master, you can get back the old master, right. So, that facility is available. Now, file based processing, you may not be able to have these kind of facilities. So, these are the basic ideas. On the other hand, in online processing, you can see that you have a transaction, you do an immediate entry through the keyboard, you are processing immediately, and you are updating the file, the master file or the database immediately as and when the data is available. So, that is the difference between batch and online. Information technology trends. So, you can see here that essentially we have various new concepts that are coming up, like multimedia, the technologies that facilitate the integration of two or more types of media such as text, graphics, sound, voice, full motion video or animation into a computer based application. Internet and websites have become integrated to modern ways of living. The web browsers now act as platforms to run computer programs, and soon the underlying Windows operating system may become irrelevant. So, Internet can be defined as a network of networks, right. The basic idea of the Internet is that it is not that somebody has created an internet and updating it, and we just go there and we find our information. It's not that way. It is basically, it is a network of networks. Do you want to join that or you do not want to join that? So, if you join that, there are certain preconditions, is that you are giving access to your files to everybody in the world. All right. So, that means by getting connected here does not mean that you browse somebody else's site with the help of web browsers. What I mean by getting connected is, you have a server and you have kept certain information in the server, and this particular information you have an address towards it that you have defined, and you want it to be accessible to anybody who want to see it. All right. Now, naturally, what you are showing, that is basically your discretion. It is not the discretion of somebody else. Obviously, there are some authorities who will determine what kind of website address you will give. Otherwise, if there is a complete chaos, then everybody may use the same address again. All right. So, you just cannot use any address, you have to find your own address, and that address there is some mechanism. But beyond that, the material that you are posting in your particular server in your location, absolutely no control is possible there. Obviously, you are guided by your country's laws. So, what basically happens, you put up your pages in the internet. Similarly, everybody has put their pages of internets on the internet, and all these are connected through a network. So, yours is a network, everybody else's are also a network, and all the networks are connected in a network. So, we have a network of networks, and which we can call as internet, right. So, it is like a huge mass and growing at a tremendous speed, and the basic idea therefore is like a platform where you can search the good things, you may even search the bad things. The most difficult part about internet is that you can get almost anything on internet. Suppose even if you want basically to know about MIS, you may get many things in the internet, but please be aware that many of those things may even not be genuine, alright, because anybody can put in anything, alright. So we have to be careful while using internet, and we should have the ability or the capability to understand what is genuine and what is not. Then the super chips. The super chips, the P6 or the power PC chips, the modern chips, they squeezes 50 to 100 million transistors on a postage stamp size silicon pad. So basically these things keep updated. Basic idea here is that the chip size is becoming smaller and smaller, and a day will come where you may have a small handheld device with a tremendous amount of computational power. Then fifth generation computers, which will be massively parallel computers, hundreds of thousands of processing chips integrated to encounter very large and complex computing problems such as finite element analysis, network search, airline scheduling problems, and so on. Uh, Flops, floating point operations per second, hundreds of billions of calculations per second is the current speed of the superconductors. Then we can have supercomputers. We have teraflops, may soon be a reality, which could be 1 trillion operations per second. Now, let us see some of the management challenges with the information technology trends in hardware. Now, you see, most of the people who have reached the very top of organizations, or who can be called as constituting the top management of an organization, most of them, they have got their degrees or education um long back, maybe 25 years ago, or even more. So at that time, we had a very ordinary kind of computer systems. So these people, they have not studied the hardware and software developments, but they have witnessed. So their learning is on the job. But what may happen, depending on the kind of designation or depending on the job title, it may happen that the technology might have passed some of them. So keeping abreast of the technological changes is a very big challenge for the management, and if that is not done, they may not be able to make wise purchasing decisions, because ultimately the top management approval is very important for an IT long term IS plan to become successful. So that similarly, training the information staff and all related employees are also going to be very important. Then after that, let us come to the information system software. Let us come to the information system software. Software on the, compared to the hardware, is a slightly different thing. Here the basic difference about the hardware and software considerations is that hardware considerations are more of what you call is like a facility, whereas the software is more of how you use it, because a facility is definitely programming capabilities, but how you use is very important. So here a lot of customization is very much required. So if you do not have good hardware in your organization, naturally you cannot support. Is a precondition that you must have good hardware. But many people think that if I have good hardware, we have a very good information architecture. But sadly, this is not so. What is happening as time is passing? Earlier the hardware costs were prohibitive, the very high costs of hardware. Say even a simple PC used to cost 1.5 lakhs. You cannot think of a high-end machine if you do not have 15 to 20 lakhs of rupees. Today, even with few thousands, 10, 15, 20 thousands of rupees, you can get a low-end PC, and you even can think of an high-end machine, Intel based, around 1 or 2 lakhs rupees. So it is you can procure hardware, but software on the other side, many people thought that it is available freely. It's not. The hardware costs might have gone down, but software costs are going up, because you see today the hardware has become more specialized. The hardware has become more capable. To use the capability of the hardware, the software also has to come up. So that much extra effort should be put in the software, and this extra effort is being put in software. So the price has to be proper. If the price is not proper, why should people develop software? So you see, to take the full capability of hardware, you have to write software which is much more sophisticated, more complex, and therefore require much more effort. If anything requires much more effort, naturally it has to be that much costly, and you should be ready to pay that price. So this is the basic dilemma of software, that today the software costs are on the rise, and maybe the hardware costs and software costs, they may be almost equal, but many organizations are really not ready to put that much money in software. What is happening? Because of this, the organization's information technology is actually suffering, right? So this is the key thing that we must keep in mind, that the hardware and software, they are two different things. Hardware is the basic capability, but software on the other side is you have to use the software. It is not that you have to customize it, you have to make it your own. To make it your own, you have to understand the software, and you have to get the right software. So if you ignore that, okay, software is something what is there, the people will develop it, you are mistaken. It's not easy. It's not even easy to obtain good software developing people. They are also very precious commodity, and even if you get them, you cannot keep them with you until unless you give them the right kind of job and the right kind of compensation. So with that, let us try to understand certain key features of software. First of all, the software is a detailed instruction that controls the operations of a computer system. A software program is a series of statements or instructions to the computer. There are two types of software on a very broad basis: the system software and the application software. Let us first see the system software. System software is a set of generalized programs that manage the resources of the computer, such as the central processor, communication links, and peripheral devices. There are various types of system software, like the operating system, interpreter, compiler, and utility programs. So there are various types. Let us see them one by one. An operating system, like your Unix, like your Linux, like your Windows, schedules computer events, allocates computer resources, and monitors events, right? Interpreter is a special translator of source code into machine code that translates each source code statement into machine code and executes them one at a time. So you see, interpreters are those kind of software which does not you do not compile them. Basically, whenever you compile something, the source code become an object code. Here the source code doesn't become object code for an interpreter. Here every source code is taken one at a time, converted to machine code, executed one at a time, and everything happens in the runtime. So with an interpreter program, you do not have to compile it, but because you are not compiling, it is slow. Compiler, special system software that translates a higher level language into machine language for execution by the computer. So, whenever you say for example, a Java program, when you compile, you get compiled object code, and these object code actually executes whenever you are executing this particular program. Then the utility program. Utility program is system software consisting of programs for routine repetitive tasks which can be shared by many users, such as a sort, list, print, create file, merge file, etc. So, there are various kinds of utility programs, and this is also a type of system software. Application software, on the other side, programs written for a specific application to perform functions specified by the end user. So, there are various application software. For example, you have the payroll, you have the financial accounting, you have software for materials management, software for marketing. So, you can have almost all transaction processing systems can be called as application software. Why transaction? Even to that extent, even decision support systems, basically MIS deals with the application software domain. Let us take a simple example of an application software. This is a management game on dynamics of quality fluctuations in a electronic company, in an electronic company. So, it includes a game database, pull down menus, user friendly outputs, graphic displays, online help, during the period plots, and utilities such as the game board, mid plan revision, result analysis, and various levels of passwords. So, here is a simple game environment. Basically, what happens in this particular application software, we have in the game proper, we have a database management system and the simulation programs. All right. This is basically interacting with the game database, the results and plots, the planned decisions, and the game variables. So, in this particular game, what happens? All these utilities, whatever we have talked about, like online help, graphic displays, during the period plots, game board, mid plan revision facility, result analysis, and various levels of passwords. So, basically what happens, as a player enters the plan decisions, the plan decisions are entered into the database management system, which in turn stores them in the game database, and also entered in the simulation program, and the simulation program along with the game variables which are stored in the program itself execute. So, after the execution is done, naturally what happens, the results that are obtained, these game variables, through game variables, the results that are obtained, the database management system uses them and updates these results in terms of results and plots. So, these results and plots are viewed by the participants, and accordingly they enter their next planned decision. This is a dialog chart. What really happens in this particular application software? We have the main menu, we have the help menu connected to that. The main menu has got these following options: new decisions, run the model, past trends, plan results, game board, quit game. Right? The plan results can be plan report, performance report, and the resulting plots, whereas past trends could be that of end plan, during plan, and the performance results. So, QGame is a simple application software basically used for playing with some management participants, and it is a simple application software. I just discussed a little bit about its design details, and you can see there any good application software that we have to develop has to consider the programming part, the data handling part, the database part. A database is very important here. There should be a database, and particularly for transaction processing system, database plays a very important role. So, application programming is all about how you handle your database in the most effective manner. Obviously, there will be processing, but stress should be more on the data handling. So, thank you very much. We will continue this in the second session.